Okay, guys, if we can slowly resume for the last session of the day. So I would like to kindly invite all speakers of the day to join me in this panel. We don't want to make this too formal or too complicated. We just exchange maybe a few ideas about what we feel is important for future networks. And maybe each one of us make a 2 or 3 minute statement, and then we open the floor for discussion with the audience. And then after that, we'll have a welcome reception right outside here. Hopefully the sun will go down a bit, so we're not in a huge rush. So please, guys, can you mind coming here? Ladies and gentlemen, I should say. Lady and gentlemen. And the only reason I'm sitting at the podium is that there's no chair for me. It's a topological issue. Only 6 chairs could fit. Yeah. 40, please. Okay.
Everyone.
Huh? No, you cannot. This is all set up in a certain way with certain specs and everything. And we also have the COVID glass restrictions and all of that. So anyway, good. So first of all, let me thank you. I really found this an extremely fruitful day and interesting. As you probably know, most of the time, if you attend a full day event, you get tired at certain points, etc. I don't know. I followed all presentations and stayed alert. So which means you guys did a great job. You are a great group anyway. So and I think, I mean, this is done mostly for the benefit of our PhD students. And I personally feel it was a very well-rounded overview of, trends, let's say, in networks, current and future. I don't know if I had warned you, but some of our students here are not telecom students. Some of them are power students. They deal with energy harvesting and modeling solar cells and things like that. But this is done on purpose. I mean, we've had other events that were on that side or other topics. So Chris knows this very well. We don't expect people to be experts in all the things we present, quite the opposite, to be exposed to many other things, and also to completely soft skill issues such as what we'll have tomorrow. So tomorrow the whole day is devoted on entrepreneurship. I invite you all to be there as well. Because we have people from the market, people who set up companies who failed, people who are in the VC community, in the investment community, etc. But also some academics in the entrepreneurship. The college has a very strong program on entrepreneurship. It has like 200 undergrads. And so we have several faculty members. One of them will speak. The Dean of Alba will welcome us. So I think it will be also very good for our students. Now, on the topic of this panel, perhaps then I could start with a few things that I think will be important in the future, and they relate also to the work we've been doing in PAINLESS. So I have 3 points to make. I mean, one that has to do with devices, the other one that has to do with network topology, and the third one that has to do with integration of different technologies. So my view is at the level of devices, the devices themselves will keep evolving, especially in the antenna domain. Of course, you would expect me to say that, but I really believe that we'll keep seeing many more antennas that are much simpler, smaller, more flexible, more wideband, more multi-purpose, cheaper, less energy consuming, and hopefully this will bridge the different paradigms that we have. So you'll be able to use them in handsets for eMBB, but also for IoT nodes, etc., to reconcile all the frequency bands that we have and all those things. So that's a challenge, but I think it's also a trend. But also the devices themselves will be augmented, right? So we'll be seeing, there was so much discussion today about IRS. So definitely this device will be there as well. At the level of the network itself, I think that the topology will become much more agile and mobile than what we see today. So this is really, really the beginning. I mean, I honestly feel PAINLESS in that is one of the probably first projects to make this point very strongly. the network, the way it is now, has a fixed infrastructure and a moving infrastructure, let's say. And I think we'll be seeing these boundaries to change. And we'll see much more, let's say, mobile segment in what used to be the fixed infrastructure up to now. We are already seeing that with the automotive paradigm. So in 5G, automotive is a big thing. And the idea is there that besides other things, automobiles will also act as access points or base stations, not only for peer-to-peer connectivity, but also communicating with people and users and machines around them. But also, I believe what we're trying to do here at PAINLESS, UAVs, but also other kinds of portable access points, such as robots, etc., will play an increasing role. And this will have to have an impact also on the architecture itself. I mean, this front hole, back hole elements that Professor Zanakaki showed, when you imagine that these things are on a self-buckled thing that is on the air and moving and completely standalone and is doing millimeter wave for one and some sub 6 gigahertz for the other, will redefine, I believe, a little bit the architecture. And then my final point, and I'm stopping with that, is the domain of integration. We've heard about that today. And I think that's a trend and it will continue. I think we will be seeing, for example, as Chris mentioned, integration of course, sensing and communications. That's kind of happening already. And it makes a lot of sense, and we'll be seeing much more of that. But also integration, I believe, of the power grid and the telecom grid, if I can call it like that. And you'll have telecom networks that actually give you power and vice versa. And the whole optimization of the infrastructure will be done jointly. Already in PAINLESS, we've done a part of that. So we've had, like Chris mentioned earlier, joint performance metrics and KPIs that take into account energy, not only energy efficiency, but energy autonomy, including harvesting, neutrality, etc., and communication efficiency. So that's it from my side. I don't want to say much more. Maybe we can go around. Maybe Foti, you want to start, and we go like this all the way up to George.
To be honest, I'm not very much prepared for. Yes, to be honest, I'm not very much prepared for such discussion. I have a few things in my mind without no belief for myself that I'm the most expert guy to do that. So I think for future networks, for sure we have AI everywhere. So this is also a point of interest, not only providing a solution to various problems, but how these techniques will be incorporated to future networks. Offline optimization, real-time optimization is a quite big issue, in my opinion. RISs, of course, I think it is obvious that also from today's discussion and presentation, that will be a key enabler for next generation networks. However, also the cooperation, coordination with higher frequencies seems to be very, very, very important. It seems that we had everything we could have from relatively low bandwidth. So I think that it seems that it is a necessity to go to higher bands. So for example, the D band, okay, there specifically for RISs, manufacturing RISs at this frequency is not a trivial issue. In fact, I think there are very few examples or demonstrations at D band, not speaking for higher bands. When you come to manufacturing, then you have to face with nanoscale problems. So RIS is not anymore a cost-efficient infrastructure. Becomes far more complicated. Of course, there are technical problems that maybe in 10 years from now we will everything will be solved, but still it is the case. And then taking the one of the first words of Konstantinos regarding the antennas at terminals, it seems also that terrestrial cooperation of terrestrial with non-terrestrial, or integration with non-terrestrial systems will be also very important in future networks, and especially it seems to attract attention the direct access of the terminal to satellite, low Earth orbits, LEO satellites. There is also a call at ESA, the European Space Agency, exactly on that, direct access of handheld terminals to LEO satellites, and we're speaking of frequencies around 26, 28 gigahertz. So making a very simple link budget calculation, one can see that it is very difficult, especially at the uplink, because of power restrictions. It's very difficult to give to provide links that can accommodate high data rates. So antenna technologies may be new materials, minimization of their size. Of course, when you the higher you go to the frequency, the more you gain in terms of space. So you can put together more elements, etc. But yet, when we are speaking of antennas on terminals, then it is something different. You have, of course, power limitations. Thus, antenna technology plus beamforming techniques should be used, or I don't know what else, to provide this capability of really having 5G through the satellite network, but with direct access from our terminal. So these are things that come to my mind. Thank you very much.
Yeah, thank you very much, Foti. Maybe we can go on to Petar.
Yes, thanks, Konstantinos. So, I mean, I have some remarks here on all three things: device topology and integration. So first, about the devices, and also about the other trends. I mean, it's. I remember as a teenager when I was asking that my parents buy me some expensive piece of clothes. My mom was having a theory that if you keep some clothes for long enough, it becomes fashionable again. And I think with satellites is the same now, because it was not fashionable for many years. Now it's coming fashionable again. Another thing is the personal area networks. You know, when I was starting my PhD back in 2001, personal area network was a big thing. And the idea of personal area networks was to connect Palm OS, then a mobile phone, then some goggles, then something on your hand, and so on. Suddenly, 2007, we have iPhone that includes everything there. And now it seems that we are again disaggregating because we want smartwatches, tags, and so on. So I think this kind of short connectivity, personal area networks, and so on, are going to become interesting again, connecting these devices. So speaking about that, at the device side, I think we are going to see some departure from the mobile device centric towards other devices that we put in the environment, on objects, IoT, and so on. And more speculative is whether every wirelessly connected device should have a transceiver in the future. That's another point, because this device might just modulate whatever backscatter, as also Ioannis was showing. Maybe that will be another way to communicate without having a transceiver yourself, or you're going to get energy from somewhere else, right? Which will be used maybe for computing. It's easier to use the energy for computing rather than for transmitting, again, seeing the values that you were putting there that were harvested, right? So on the network topology, I agree with this combination of moving and static. Again, satellite is a topic and direct connection to the satellite. Although I think this idea of going to small cells and having high densification maybe didn't happen as people have been seeing. Actually, we have seen more convergence towards massive MIMO, and there are many reasons for that. I mean, on a paper, it looks great to put many access points. In reality, you have to pay for all these sites where you are installing them and so on. So it's not that easy, right? And an integration, I think that's probably one of the most exciting things that is happening at the moment. But from an integration point of view, I think there is a lot of things to understand about the system design. Because in communication, just to make it simple, in communication we have digital data, and we can say what is the provenance of that data, right? Who is producing that data? Then in localization, we have analog data, right? Based on these localization signals, we can say what is the provenance, so who is producing these localization signals, whether it's RIS, device, and so on. And then finally, we have sensing, where we have analog data, right? And we are uncertain about the provenance. We don't know whether the object that is reflecting is the one that we want. So we have to figure out in a different way. So I think putting all these three into a system, and actually it's not localization only, it's positioning, which is more general, also orientation and so on. So I think will be interesting for this area, definitely. So I don't want to speak about machine learning because that's kind of assumed now, but I think this integration of these three things is definitely something which is going to be big.
Great, thank you, Peter. Maybe we can go on to Anna. Even though you pretty much said everything, but in your talk.
Yes, I think I will repeat myself a little bit. Am I audible? Okay, indeed. However, I agree there is a lot happening at the technology level. RIS, for example, is a topic of great interest. Massive MIMO solutions. Another one that I will pick up is self-free MIMO. And this brings some really interesting architectural concepts because it's this increased degree of flexibility, this user-centric architectural approach. And then the other interesting part is not only how the technology works, but how do you handle control and how the control propagates from the access further in to the network. Because, for example, the transport can play a very, very important role. And this architectural solution with distributed units and central units, how can this facilitate the operation of a solution like this? So what happens at the technology level, I think, always propagates higher up. And then brings in integration, right? The challenge in integration. So I think integration is a key message to bring forward. There are a lot of challenges there. The heterogeneity of technologies is quite extreme. So it's actually a very challenging problem to solve. I think AI type of solutions are very relevant, is a big enabler. We find this at different parts of the network, very technology-oriented solutions, very system-level solutions. I think it's very well put. And I will agree also in the context of integration of technologies like, for example, NTN, we see satellite coming into play more and more. And it's clear, I don't disagree with the fashionable aspect, absolutely not. But there is a clear need because of services, right? Because of connectivity requirements. We need further and further user-centric solutions. So if you have people traveling on a plane, how do you provide services? How do you provide services on a boat in the middle of the ocean, and so on and so forth? So you can see the real need for this type of solutions as the services also evolve in parallel. So we see this more and more, and I think there are important technological challenges that are there to be addressed.
Great. Thank you, Anna. On to Chris.
Okay. Okay, right? Okay, I mean, a lot of what I had in mind has been said. Maybe the one thing I'd like to add is that I think, and maybe it's a thought or maybe it's more of a wish, that a lot of what happens in the future will be also driven by global challenges, such as, connecting the unconnected, or climate change, which is a big thing. And I think in that sense, Painless already is at the right track. And I hope maybe 5 years, 10 years from now, we can look back at Painless and think, oh, we're doing something before it was cool and before everybody, started working on it. Because I think this integration, there's going to be a need for integration with clean energy, with renewable sources, and a deeper integration. And that penetrating in how we design the network and how we manage network traffic, but also energy and migrate energy and energy harvesting, wireless power transfer might give us options there. And again, if I think of climate change, another aspect is probably hardware reuse. So all this hardware, all this, devices that we want to deploy everywhere, they are a source of silicon consumption, and that has a lot of implications. It's more and more difficult, also for geopolitical reasons. So hardware use, I hope, is going to be an important element. And that's another gain I see from this integration of functionalities where, you have devices doing multiple things and you don't need to recreate or, duplicate hardware and so on. So I'm hoping this somehow finds a way to translate into the next generations of cellular networks and other networks as well. And on the topic of integration of communications and sensing, it seems like the first one to get there will be driven by the connected vehicle, where it seems to be things are, happening first. But hopefully, it's like many other technologies, we'll see, this being adopted in more kind of, classical, let's say, scenarios and paradigms by other applications. And I'm hoping to see a lot more of that. There's scope in doing it with drone networks, and there's many medical applications of this, and I hope to see this penetrating a lot of different key applications for the next generations as well. That's probably all I had to say.
Thank you very much, Chris. Ioannis?
Okay, so my colleagues mainly cover almost all the topics. Probably I can mention some other enabling technologies. Let's say the semantic communication, which is, I think, is a key technology for 6G, where you transmit also the meaning instead just the bit stream. In terms of antenna technology, I will mention the liquid antennas, which unlock another dimension, the shape. And also wireless power transfer, I believe, is a key technology. So I work on this for 10 years now. And I still believe that will be an enabler for 6G to maintain sustainability, power sustainability of the devices. So that's all from my side.
I thank you, Yanni. I'm wondering what's left for George to say.
I had one hope, just to add something fresh here, but Yannis just diminished that. So, okay, I have nothing more to say. Just will tell you how I spent my previous weekend. No kidding. So, indeed, all of the things that we have been discussed before, they're really interesting regarding 6G. But I was wondering, what are the things that have not really tamed, and what has changed through these years? If you recall one of the slides that I showed today, I think it's really interesting to see how much of the research that is being conducted in papers is in one way or another being discussed in the standards. I think this is something unique. You see so many technologies being out there in papers, which industry takes seriously under consideration. Why? Because we have needs, of course, various needs, and it seems that wireless is everywhere, converging with many other different aspects of technology. One thing that I would like to emphasize here, because it most probably has not been pronounced really well, is the material sciences, and how relevant this can be to wireless. People are thinking of novel materials, all these metamaterial discussion regarding that, being part of the wireless network infrastructure. But certainly there are things that we have not tamed. And I was thinking, and this is very relevant to the discussion that I had with Peter, not only today, but various occasions in the past, we have not really tamed interference. I feel that we have not tamed that, which mainly, in my opinion, has to do with the way that we design control channels and the way we integrate all these technology in the network. Apart from doing, let me judge them, this trivial extension to go to higher frequencies, densifying, getting closer, but still there are items that we have not really addressed, I believe well. Of course, now, another thing just to advocate on what I have said today in my talk, the fact that we're actually incorporating into the network, apart from the typical intelligence from the transmit-receive part, that we incorporate other elements of the environments that could be, let's say, passive, team members of the wireless communication, something super interesting, and it can be used in various ways, either as a standalone operation or as operations to help the rest of the network. Emphasizing here once more the material science and the fact that it seems that we're deploying wireless everywhere, and there's a back and forth with different technologies. We see, for example, that the automotive sector has triggered many cool applications. I recall myself when I heard for the first time the drones, I said, drones, what is this? Who is going to use it? Is it so fascinating? And apparently it is. I was totally wrong, which creates a lot of interesting problems. And this brings me back to a paper actually co-authored by Konstantinos here when I met him. You recall, Konstantinos, the title, Is the Physical Layer Dead? Apparently it's not at all, right? And it's still here and it continues to be. I had this in mind and I wanted to emphasize it. Why? Because we have materials, we have new applications that drive the research towards that. So I'm not going to advocate on the technology that we discussed today, not even RIS. I'm working a lot of that. It seems that it's going to be part there. It is. The smart repeater option is there. The need for having conservability in terms of energy and being able to smartly charge our devices is factual. And people are using already working on that, even in the standards. And I think we have a fascinating future for what we're doing, and this will continue at least for 10 years. And of course, always the future is here to provide, to surprise us. Thank you.
Thank you very much, George. Let me just say that I agree with all these points. I would like actually to perhaps overemphasize some of the things you said, because it's not a coincidence that you see standards taking into account the papers that this community is writing. I mean, this community is working, in the previous stage before the standards, and also it's not an accident that the industry is adopting, because the industry is being part of this, right? And as we saw before, we have several industrial members here who are working with the, let's say, more academic research community in joint projects. In Europe, it's something that Europe does very well, right? The fact that the European Commission programs, by design, incorporate industry and even in leading roles has an impact. But even more, at a more high level than that, and maybe this is something for our young people here to take into account, doesn't mean that it doesn't happen in other fields as well. It happens in several other fields. But personally, I have this feeling of, let's say, satisfaction that if you look back, 5 years ago, 10 years ago, 15 years ago, 20 years ago, the things that were being born back then, one way or another, have found their way into impacting our lives, right? System society. So these standards that come out, they keep incorporating whatever was distilled out of all this research that was happening back then. And it's extremely gratifying, right? Even it's not like we did this, but we participated in small bits and pieces that found their way. That's the most gratifying feeling for a researcher, right? That what you've been doing didn't end up in, in oblivion land, right? It finds its way. And these wireless networks are a domain where this happens a lot. Let me turn it to the audience. If there's any, you have a very select group of experts here. So, I you may want to take advantage of that. Any questions, any considerations, any wonders, any worries that you may want to ask also regarding your future career? Yes, Igor.
So I want to ask a question that I've been asked by many people who are absolutely no in telecommunications or have ever known anything about wireless. And that is why we have to use, Wi-Fi here and then the SIM cards here, but then it doesn't work there. Wasn't the whole cellular infrastructure made so that we can have this general model where you just put your phone on and then you have data everywhere and you don't have to fight with all the systems? So I guess my question is, I propagate all this information for everyone who didn't quite catch what wireless communications and how difficult they are to manage, especially in these special case scenarios like massive access and various different verticals that we have in the communication systems. How easy it is for us to kind of converge to a general system of communications, at least for best effort.
Who wants to take that? I can say one thing from my side, very, very high level and basic, okay, which is the following. There is money involved in all of this equation, and the market finds ways, okay, to take advantage of every situation through the relevant player in a cost-efficient way for the relevant user. Meaning, for example, if you have a cordless phone in your home, and the cordless phone is something we've been having for 30 years now, okay, how likely is it that you will accept anyone to charge you for using that cordless phone, right? You will never accept anyone to charge you for using the cordless phone, because if they push it too much, you go back to a non-cordless phone. Okay, you have a phone service at your home, and it's let's say luxury for you to detach from it and walk around with a cordless phone. If people start charging you €5 a month for this, trust me, you will stop using a cordless phone. That is at the core of why Wi-Fi and cellular have been two different worlds. Okay, because cellular charges you. Okay, and Wi-Fi does not. It does not under the condition that you already have service up to a certain point. Okay, so as much as you want to integrate with Fotis, actually, I remember 22 years ago, we're doing simulations about integrating Wi-Fi and 3G for MIMO, right? He was doing the simulations, to be exact. Okay, and yes, it's working. Those simulations, okay, were relevant compared to what's happening now. This was part of several proposals back then. You know what? You have a phone that you go around and it follows you. When it's in Wi-Fi, it switches to Wi-Fi. When it has, cellular, it will switch to cellular. That's what happens today. Okay, but still the Wi-Fi will not charge you, right? And still you always prefer the Wi-Fi when it's available, because it's free, because it burns your battery less, blah, 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 blah. So this holistic view, everything in one, is not always applicable because there's different stakeholders. That's my take on that. I don't know if the panel has other takes, but it's a very natural question, of course. No.
I mean, this is, I think this is also partially to the fact that we are a little bit spoiled in a sense that, with 2G, we first time got a system for roaming and so on. And now we have Wi-Fi and we want everything to be converging. Remember that before that, you had to go to the phone and stand next to it and talk, right? With 2G, we got this mobility. But I think we are moving towards convergence. What I mentioned for satellite, I totally agree. It's not only fashionable. It's just there is actually need for convergence to be very concrete. If you have a container which is being tracked, you want to buy one module, and this module to connect to a cellular network or to a satellite, and that's, for example, NB-IoT. So with NB-IoT, it can do that. So there is a convergence on that, and the question of whether you can provide this basic convergence is, I think, as convergence of services and basic connectivity is as controversial as a universal basic income, right? In a sense that you could have certain bit rate which is given to you anywhere based on satellite, Wi-Fi, or whatever. But at the moment, I think this seems not possible, at least to me.
George, you wanted to add?
Just to add something here, to emphasize the timing aspect. Definitely there is the policy involved. I recall from my fresh industrial experience that some technologies discussed even today, for example, I'm talking about energy harvesting. While I was working theoretically, while being there, nobody cared in the company. So the motivation was complete. I mean, don't work on that. Apparently now a lot of people are working, and even industrial partners actually interested in that. This is also relevant to the discussion we had before about technologies and come and go, right? They become in fashion, then not, but it seems that the applications drive them. So there's definitely the policy, but it's also the evolution. Things are evolving. So there are different, let's say, applications, and we have the time evolution goes towards convergence. For example, we can even see here today some operators where when you are close to the proximity of a Wi-Fi, you get the voice over Wi-Fi. This is a service that is being provided. Apart from that, who could imagine some years ago to having, we don't have it yet, but there are certain discussions under Open RAN. So it means that you have infrastructure that can be used by various operators and then envision new players in the market. So I'm trying here to advocate on the fact that we're going towards convergence. Now, what's going to be the end point? Nobody really knows. But even those, let's say, strictly closed entities like industry, which makes sense to try to empower their profits, they're thinking of these convergence actually points, and I believe that it might happen in the future. Not explicitly what you said, but I feel that we're going towards that, this direction.
Can I add something to that? There's another example, very relevant, okay, which is in line with the fact that technology sometimes finds its application at a different timing, not only because necessarily the application is there, but because the stakeholders are there. Okay, so technology is not by itself, it does not have universal business value. It needs to be also useful, in a profitable way to some stakeholders. So tapping on George's example about spectrum sharing, basically, because that's spectrum sharing. In the old days of cognitive radio, and that's one Chris remembers because we had that FET project called Crown. That was one of the first ever projects in cognitive radio. Okay, it was a FET project. There was, this concept was in there. Okay, 2009. The concept was there that, what was cognitive radio? Cognitive radio as a module was a smart radio unit, okay, that could understand what's going on around it and do smart things. For example, if one channel is occupied, use another one, right? Or if there's interference here, steer your antenna there, things like that. Okay, but then it became a very political issue, okay, because once you have this super smart radio, okay, you can start making claims that, I can start operating my own network, like a Wi-Fi network here, okay, and at the same frequency that the cellular operator has bought for some hundreds of millions euros, okay, and has exclusive right of use, and don't worry, I'll use it, and I'm so smart that your customers will not even perceive that, not realize that. So it's a very modern concept, right? Why should we leave the spectrum unused if somebody can use it in a way that doesn't harm others? The resistance of the operators, as you can imagine, was humongous. Okay, they fought. Like you said, your own company fought that concept because at that time it was not making any money. And nothing personal, right? It's only business. Okay, so same thing back then. This was a threat to the operators because it was threatening their business model. They were paying, at some point, all of Europe had paid 50 billion euros to buy 3G licenses. You guys remember it. Of course, then somehow this money was given back, etc., because the crisis came and the 50 billion didn't stay there. But we're talking billions, okay? And these billions buy you the right for exclusive use, even if you have it vacant. It's like you buy a luxurious house it's like a secondary home. You have it in Florida or somewhere. You want it empty all the time for these 5 days you go per year. You don't want anybody else to use it. And people come out and say, why? You use it only 5 days per year. There's another 360 days. I'll clean it. It will be perfect. No, I don't want you to. Okay, so that's what the operators were doing. And then and we were saying in the project, but from a technical viewpoint, okay, the operators, in fact, could work in a way with those unlicensed users. Spiros knows the story very well because he was in that in a follow-up project of this one, in a way that both win, right? So you can bring the unlicensed users, those that don't have the exclusive license, and the licensed one together, and if they cooperate, okay, honestly, and of course you need the regulator to check this honesty, etc. Okay, then everybody wins. Still, the resistance was high. Well, guess what? Another 6-7 years later, suddenly there was a business model that was relevant to the operators. Why? Because the operators started running out of frequencies, my friend. And there was a crisis, and their millions were out. Okay. And then suddenly the regulator started saying, you know what? We have this unlicensed band, and it's unlicensed for all. Everybody can go in. So now the guys who are used and addicted to the exclusive right of the license, now they said, you know what? Yeah, that's good, but what's wrong with using some free spectrum as well? So now they start competing with themselves, right? They start using this unlicensed band at the CPRS, the 3.4 to 3.8, etc. Okay, to start giving license for their own service to their own customers through an unlicensed band. And suddenly, this technology is good because it's spectrum sharing. And of course, we won't interfere with you. We won't interfere with our own systems. We have technology for that. Who developed the technology? The guys you were fighting. Okay, so those things happen, and they're very interesting lessons in technology because, you have to take everything into perspective. Still, this community develops the technology and typically let others find out who can benefit or not. Okay, so that's my take on that. All right, any other points? Okay, if not, I think we can close the session for the day. I really want to thank you all. I hope it was very useful for our students. I really want to thank again all the invited speakers and guests here. It's great to have you all together in this room. And I think there is a welcome reception in the program. I don't see activity there, but there's supposed to be a welcome reception out in the terrace. And then see you all tomorrow. Thank you very much.